Yeah. Means that it's x to the third, and I have a double root at -4. So this double root means what?
X squared.
X squared. It's going to be a squared factor. So my factor is going to have to be squared. And then a root, a is for a single term, right?
Yeah.
So this factor is just a single factor. So then it says that it must go through the point 2, -36. So this is my input. If I input 2 for x, my output should be -36 for y. Okay? And so we're going to find the function and put it in polynomial form. Polynomial form is that we're going to write it as x cubed plus x squared plus x plus a constant. Okay? So we're going to have to, in the end, do some foiling and distributing. Okay? So here we go. Based on what it told us, we should know that if our root is -4, how did I get that root? Where did it come from? What factor did it come from?
2 and -2. So, I don't know.
If a solution of a factor is -4, what did that factor have to be?
16?
2.
16?
2.
Fx squared.
2. Wait.
4.
It would have to have
Well, you
been
have to,
x plus 4.
I'm trying.
If my root is -4, then my factor had to be +4, because -4 plus 4 makes 0. Okay? And then we know that it had to be what? Square, because it's a double root. Okay? If my root is 0, what did my factor have to be?
0.
X. It just had to be x, right? Because x equals 0. Hey, Masha, you think you should turn this way to learn?
Well, I'm beating everything.
You need to call Fatima.
Okay, so notice how I left the space in between my equal sign. We're going to have this parameter. We're going to call it a. A means that we're going to make this a unique polynomial.
Unique.
Okay, it's unique because this polynomial has to have, what point did it say? What point did it say? It has to have 2 -36, right?
Yes.
So we're going to use that parameter a to help us figure out what is a, so that this could be a specific polynomial that has 2, -36. Okay? So that, if we talk about input and your output. So if I input -2, what's the -2?
Yes. No, 2.
+2. I was like, that didn't feel right. If I input +2, I need my output to be a
Negative.
-36. So if I input 2, my output needs to be -36. When I'm written in function notation, what does that mean about this 2?
Why? Everywhere you see an X, you put 2.
Exactly. Everywhere I see an X, I put a 2. So this equals a times 2 plus 4 squared times 2. There used to be an X here, and there used to be an X here, but now they become 2's. So once I'm here, I'm just going to do simplify it, right? Get a by itself. So I have -36 equals a times 6 squared times 2. And what is 6 squared? 36. And what's 36 times 2? 72.
Oh, okay, 6 times.
How do we feel about solving for a so far? Is it terrible?
Give me a second.
It's the same as solving for x. Yes,
Where'd
sir.
you get the 2 from? You just pick it?
So no, the 2 was given to us. It said that this point 2 -36 has to be on your function. Has to be part of your function. So this has to be part of my function. That means that if I plug in 2 for x, what do I get for my a? What would my a have to be?
Who is it? Answer.
All right, so someone asked, Trey, was I answering your question before? Okay, so right here, so we have this 2 and this -36, and it says that it has to be part of our function. So because it has to be part of my function, I have to figure out what can a be, so that when I plug in 2, I get the answer -36. And that's why it has to be there.
Wait for the answer to 72.
Okay, so I need to divide. Is A by itself yet?
No.
No. So I'm going to divide both sides by 72. Okay, so negative 36 divided by 72. What's the relationship between 36 and 72? Negative 1/2. Okay, 36 is half of 72. So therefore my A,
With the 72, is it a negative or is it a positive?
the 72 is positive.
Are you sure? Probably be
Huh?
positive. It's like, oh wait, hold on, it's negative 36 I and it's negative 30.
Mhm.
Wait, no.
So it's going to end up being negative 1/2 because I have a negative 36 and a positive 72.
Yeah.
You see it? So therefore A is this guy, right?
Right.
-1.5.
A equals negative 1/2. So therefore my, what's this guy? My
Polynomial.
my factored form polynomial, my A is actually f of x equals negative 1/2. I'm going to put x in front times x plus 4 squared. So that's my answer in factored form. Does it want it in factored form?
No.
No, it wants it in what? Polynomial form, which is what you were doing with your classwork yesterday, right? You were taking things from factored form to polynomial form. Okay, so that's where you had to FOIL and distribute, and at the bottom it had to look like a full-on polynomial. So the first thing we're going to do here is FOIL, right? Because we have negative 1/2 x, and that square means we have x plus 4 times x plus 4. Agree or disagree? Okay, so what do you do with two binomials?
Ready?
I distribute them, I FOIL, right?
Yeah.
I'm going to get red at some point.
Oh, okay, because that's a 2, so you do it 20.
Exactly, because there's a 2. So I have x squared, 4x, 4x, 16, right?
Yes.
Are we okay with that?
Let's go.
Did I lose anyone there with the FOIL?
No.
Okay, can I scoot my board over
Yeah.
so I can write it? I'm going to write it so I can have more space. So now we have negative 1/2 x times x squared plus 8x plus 16. How did I get 8x?
Because you added the 4x's.
Yeah.
Exactly, I added my 4x's together. So 4x and 4x makes 8x. Are all my parentheses gone yet?
I thought,
Where did the x come from?
No yet.
Which one?
The x right here is like the negative 1.
It's the x that was on the outside. I just moved it with the number.
Okay.
Okay, so now I gotta distribute. So I'm gonna distribute the 1/2, the negative 1/2 x, to be very specific.
Gotta get it right.
Sorry. So negative 1/2 x times x squared is perfect. Negative 1/2 x cubed. Negative 1/2 x times 8x.
4x.
What kind of 4?
Negative.
Negative 4x squared. And then negative 1/2 times 16. What's half of 16? It's a negative 8x. So this is my unique function that fits the situation.
Now you check it.
If you were to check it, you could take 2 and plug it in and see if you get negative 36. And if I get negative 36, then I know I did it right. If I can also check it with my factors. If I take negative 4 and plug it in and I get 0, then I know I did it right. Or if I take 0 and plug it in and I get 0, then I know I did it right.
Right.
So there's various ways that you can check it. Main thing is taking your 3 points and plugging them in.
on the negative 1/2 x, did you just move that x down with the n closer?
Yes. Just so they could be more mathematically written, correct? It just looked lonely and awkward out there. So, all right. So now we can graph it. What type of polynomial is that?
Cubic.
Negative.
A negative what?
Negative odd.
A negative odd. Perfect. I have a negative odd, which means I have to end negatively, but I start positively. So I have negative 4 and 0. And at negative 4, what happens? Well, what happens at negative 4 specifically?
It doesn't.
It touches it, right?
It touches it, right? Because it's a double root. So I'm going to touch not go through them. Have a little bounce there. So I'm going to bounce and then continue.
Oh, that was actually really good.
I think I did fairly decent here, y'all. Thank you. I tried.
No, Miss, you messed up.
Shh. Okay, so do we understand every aspect of what we did? Was it that terrible?
Yes, it would take like 10 minutes just for
Because we're learning it. It goes faster when I'm not having to tell you every little detail. All right? Okay, let's try another one. So this time, instead of giving you words, I'm going to give you the graph. And we have to figure out what function made that graph.
Oh my.
What function made that graph? So the first thing you want to do is analyze your roots.
It's not a double root.
There's no double roots. Are there any triple roots?
Yeah.
There's curves? Remember?
No.
No, they're all single roots, right?
Yeah.
All of them are single roots.
Negative R?
So it's going to be a what?
Negative R.
Negative odd. So in my mind, I know I'm looking for a negative odd polynomial, right?
How do you know they were all single roots?
Because I go through them, right? So at -4 I go through, at -3 I go through, and at 1 I just smoothly go through. I pass through it. Okay? And then Jose, why did you say negative odd?
Because it starts off positively and ends negative.
I start positively and I end negatively.
And you have 3 roots.
And 3 roots is also an odd giveaway. All right, so let's write our factors. So each time we do this, it's going to be f of x equals your unique a. So what a is going to make this work? What are my factors? How did I get -4?
X plus 4.
There we go. That came from x plus 4. How did I get -3?
X
X plus 3.
And how did I get 1?
X minus 1.
Perfect. Okay. So I have those. And what's my unique point that's going to help me find a?
-1 and 12.
-1 and 12. So if I plug in -1, I should get 12 as my solution, right? So wherever there is an x, it becomes a -1.
Did you multiply the 4 and the 3 together to get the 12?
No, it gave it to us. It says here's your x, here's your y. All right, find my a. Find the a. All right, what did y'all get for a?
-1.
Good job.
Yeah, what he said. I thought we was going through classes.
So we have a. I just wanted to know before we went, like how slow I had to go, or I could like do it really fast.
You can do it really fast because you got -1.
Good. Good job, guys. So you end up with a 3 times 2 times -2,
Negative 12.
-12a. And then divide by -2, 12,
Yeah.
and you get
-1.
-1. So you have your a. That's part 1. And now I'm going to plug a in, and then I'm going to FOIL and distribute to find my polynomial. So we're going to FOIL and distribute. So we have -1 times x plus 4 times x plus 3 times x minus 1. Remember, when you multiply, you only can do 2 at a time, right? So I'm going to do the first step, which is your x times x times 3, 4 times x, 4 times 3, and it's going to give me -1 times x squared plus 7x plus 12. Has anyone caught on to the shortcut of how to do those? How to mentally do them?
Yes.
Have y'all caught on to the shortcut to mentally do this?
I have.
What do you do
I
with it?
probably have, but I haven't.
I mean like x times x is x. 1 plus x is really 1, so 1 plus 1 is 2. So you put squared, then I do
You
x
add 'em?
plus like
Yeah, see,
kind
the
of
middle is
sense.
just adding your ends.
Yeah,
To get the last, you just multiply your ends.
yeah, that's kind of
That's it.
basic.
That's what you do in your head, man?
That's what I do every time. All right, so.
crap. He's just saying them. Look at him.
All right, so now I'm going to have to distribute again because I still have parentheses, right? Gotta get rid of these bad boys. So, Alan. You see what you did, Alan?
You leave.
And now your boy's gonna be off.
Yeah, Alan.
It's like the end of the world or something.
It is.
She hates doing that.
For real.
See, man, this is what I get. when I
He
start
gets in
learning.
trouble when he tries to learn.
He was stretching. All right, here we go. So then you're gonna just distribute. At,
X3.
so I end up with -1 times x to the third minus x squared. What I do to this term, I'm gonna repeat again for the next two terms, right? So I have 7x times x, and that gives me 7x squared. I have 7x times -1, that gives me. I have 12 times x, that gives me. And I have 12 times -1.
Oh, no, I like trying.
So we distribute it. Combine my like terms. What are those?
The negative x squared.
Exactly. Negative x squared and positive 7x squared make? Perfect. Negative 7x and positive 12x makes? 5x, which you didn't say. Are my parentheses gone yet?
No, you gotta
No.
distribute again.
What do I have to, what's the last thing to distribute though?
The one.
The -1. And what is that -1 gonna just do to everything?
Add
Turn everything
negative.
negative except for the 12.
Change their signs, right?
Yeah.
So I end up with f of x equals negative x cubed.
Negative 6x squared, negative 5x
There we
plus
go.
12.
Beautiful. And we are done. It's multiplying and adding. Multiplying and adding. Multiplying and adding. It may be a little time consuming.
No, it
Little,
definitely
it's
is.
about
It may
15
be a little
minutes.
time consuming.
Not a
Just a
little.
smidge.
Not a little. A lot.
You have 7 minutes.
All right. Let's flip it. So on the back, we're not going to expand. We just got to find our A's. Okay?
That's a lot of work.
On the back, we're just going to find the A. So we're going to just see. Look how little that work is for finding the A.
What?
All we're doing is
All we're doing is finding the A on the
Oh,
back.
I thought you meant we had to go through
No.
the process. We said it's gonna take
Wait,
five for the 7 minutes.
So on the back, we're just going to find the A's. Got it? So before you do anything, you're going to analyze your graph.
So we have 1, 2,
Even.
3.
So it's an
Positive?
even.
It's even.
It's an even positive.
Wait, how did I even know that?
It's even positive. It's 4 roots.
I have 4 roots. I have a single at -3, a double at 2, and a single at
Oh, okay.
4.
'Cause I
We see
can't-
them now?
Yep.
Single, double, single, eggs.
How does that make it a double?
My head thinks.
Because
black.
it
Did I-
actually
did I
go
go
through
through?
it.
Or
It
what did I do?
bounces. It bounces.
I bounced. I touched it. Remember, if it touches and continues, then it's a
Double.
double.
Double root.
Also, if it goes through, it's a single.
It's a double root, right?
It's a double root.
So what? X
Okay, so that
minus 2?
So that means I
X,
have it to the squared.
X minus 2 squared.
Good job. So I have A,
X plus 3.
X plus 3,
I hate
and then
this before you get out.
X
minus 2 squared,
2 squared.
and X, is it 4?
Yeah, minus 4.
Alright, so I have my beginning factor. It says for this, my unique point is
-2 and -24.
-2 and -24. So when I plug in -2, I need to get
24.
-24, right? So wherever there's an X, it becomes a -2. Less you in advance. Alright, find A.
Find the A!
Remember, multiply, then add, multiply, divide. Add, multiply, divide.
How did you get negative?
Alright, so here we go. So when we went through, we had -24 equal A times 1 times -4 squared times -6. Agreed? Alright?
Yes.
Are y'all still with me?
For now, yeah.
Still here.
Okay. Thank you. Have fun, Mara. Alright, here we go. So we have -24 equals A times 16 times -6 What is 16 times negative 6?
Negative 96.
So I
Negative.
have negative 24 equals negative 96a. And what do I do to get a by itself?
Divide by.
Divide by negative 96. And that gives me
1/4.
1/4. So a equals 1/4. So your answer would be, I'm going to be lazy, that. 1/4 times x plus 3 times x minus 2 squared times x minus 4. And that would be your final answer. Because it asks for a factored form. Not polynomial form, but just factored.
So you would just put
4th in the place of the a.
That's all?
That's it?
What else
Miss,
you
but
write?
like, what happened to the one where they?
Well, 1 times anything is what, Alan?
So,
It's just itself, so.
So, yeah.
Okay, really quick, I just wanted you guys to look at 4. Notice on 4, negative 4 is what kind of root?
A cube.
What is it?
Cube.
It's curved through it,
It's a
so it's a
Cube?
triple. It's going to be a cube factor, right?
The fact that I knew that.
Okay, it's a triple.
The fact I didn't do that.
It's a triple.
Well, I guess because I get bounces and then it's like goes through it at the same time.
I mean, like,
So
no.
you
it's
should
3.
you would end up with x plus 4 to the cube power times x minus 1.
hey,
This is
Carlos.
how- no, this is the cube.
Wait up, man.
It's, you can literally see the cubic in it. And then you see the linear. All right, guys. Happy Thanksgiving. I won't see y'all tomorrow. Please do your classwork.
I guess.